Welcome everybody. It's January 17th. This is our first 2023 Diatom Web Academy. I'll let Mark introduce Bart here in just a second. A few little news items. I'm going to post them in the chat here. There's if you saw Sylvia's email, there's a postdoc opportunity working with Diatoms at the USGS. There is a doctoral PhD opportunity at University in Prague. And then there's a very interesting story about ongoing research funded by the US EPA to combine ecological information, diatoms, light microscopy, and eDNA to further refine the utility of diatoms in environmental assessment. There's a link to the news page on diatoms.org about it. If you guys have any news that you'd like to include in at the end of this Diatom Web Academy or in future Diatom Web Academies, please feel free to reach out and we'll try to spread the good Diatom word. And with that, Mark, take it away.
All right, thank you, David. Thank you, David. And it's my pleasure to introduce our guest today, Bart Van de Vijver, who's coming to speak on being a detective in our museums out there, looking at collections and how we can better use them and better interpret them. Bart is at the Botanical Garden in Misa in Belgium, and also a teacher at the university. And his work tends to focus on biogeography, ecology, taxonomy, and museum practices. Without further ado, Bart, please take it away and welcome.
Okay, thank you. Hi, everybody. I modified slightly the title. I'm not going to talk about the detective in the museum, but I'm going to talk about Puero in the museum. And for those who don't know who is Puero, Puero is the famous Belgian detective invented by Agatha Christie, here in the form of David Suchet. And he was Belgian and he was a detective. So I thought maybe I should not compare myself to Puero, but use his name on this talk. This is not a solo slim work. This is a teamwork. And I start to thank all the people that helped me. I see David is also listening to me, so I have to be careful what I'm saying. But I thank Paul, Wolf-Henning Kusberg, Carlos, and Tanja Schuster, who is the curator of the Grunow collection in Vienna. And of course, there's one person missing, and I actually dedicate this talk to Luc, one of the most motivating people I ever met and who passed away too soon last year, and he will forever be my colleague and my friend, especially one of my best friends. But anyway, why this quest for types? What is the idea about types? And I'm going to give some personal observations. They are not published, and this is just some feelings that I developed the last 25 years doing Diatom work. The first one is maybe quite shocking, but about 40% of all published images are probably not or only partly correct. It's not that people make mistakes, it's that people, are sometimes not critically enough about what they see or don't have the tools to what they see. And that includes also my own work previously and probably also what I'm still doing from time to time these days. Secondly, a lot of commonly known diatoms are insufficiently documented. Everybody thinks they know Navicular gregaria or Fragillaria capucina, but do you really? On what basis do you know this species? And some of them we think they are documented, but they are not that well documented. A lot of the present day information is based on interpretations of interpretations, which means that people think that they see a species, they document it, and other people base their idea on that document that is actually also based on an idea that people have. Fourthly, types are often still available for analysis. The only problem is you have to look for them, you have to search for them, and sometimes it's really going through dusty boxes in a basement. And that means that a lot of types are rarely well evaluated. Now, I want to show one slide from one of my colleagues at Botanic Garden. He's a higher plant botanist, like Mark Joseph. And last year on a talk for students, he says, all biology starts with identification. And I think that was a very nice slide, and he allowed me to use it in my talk. So this is actually a very interesting slide. Of course, this was for higher plants, but I think we can also use this for diatoms. Now, what is a type? And this is something that David Williams cannot stress enough to me, that it's actually just the element to which the name of a taxon is permanently attached. So the only thing what I try to do is to find the correct name of a taxon for the correct element and give the name to a face. In botany, a type is either a specimen or an illustration, which means that also the 19th century illustrations we can use as types. It doesn't have to be a specimen if there is no material left. And then you have this whole plethora of names. You have holotype, isotype, lectotype, neotype, syntype, epitype, and so on. But there are very nice talks about typification on the web. I'm not going to give you a course on typification here, but there's a lot of different types going on in literature, and each of them has its own value. Now, if you want to know more, my colleagues, including Mark Sosef at the Botanic Garden, wrote a very, very, very handy and very easy booklet, about 80 or 90 pages, on botanical classification nomenclature. It's freely available. You just type in that title and Mark Sosef, and you can find it from ResearchGate. You have it in English, you have it in French, and I think you also have it in Dutch for those who want. Now, some more extra thoughts is that diatoms, as we all know, they exhibit a broad variability in size and shape. But because of species drift and force fitting, that means that you try to identify a bird in North America using a book from African birds. That's force fitting, but that's what you do with diatoms. You use the European books and identify species in South America. Seems to work, but I'm not sure it really works. But they created catch-all species, but that means that these species sometimes end up with undefinable ecologies. I will give you some examples later in my talk. Now, we also know that many diatoms actually do have specific, sometimes very narrow ecological preferences, but because of our taxonomic concepts and our taxonomic ideas, our ecological insights are a little bit blurred, and we lose information because we think of species that are too broad. The only also thing is that with the modern communication tools that we have now, you can spread information more rapidly. You don't have to wait till the printed copy ends up in your mailbox after 2 years. So it goes very fast, and there's a lot of fast publication possibilities and exchange possibilities for information. Now, I gave this talk the first time for people in Holland, and there is always a fight between taxonomists on one side and ecologists on the other side. So a taxonomist goes for names, and he continuously changes things based on new data and new insights. On the other side, you have an ecologist, and for them, the important thing is, what does the name represent ecologically? So they want long-term stability in nomenclature, and they want it to be a practical system. Now, I don't want to say that taxonomists are only old gray men with long beards and ecologists are young people. No, it's just the common idea that sometimes people might have. But the thing is, we have to find out a workable solution to find a good taxonomy together with a good ecology. And for this, a certain pragmatism is often important from the side of the taxonomist. And I'm going to give you an example of a species described by Müller in 1788 under the name of Conferva pectinalis. About 50 years later, Dilwyn further illustrated it, and in A, you see the original drawing that Müller made, and in B, these are the drawings that Dilwyn added to it. So that is Conferva pectinalis. 1819, 16 years later, Lyngby, the Danish guy, describes the genus Fragillaria, or Fragillaria like the English say, and they add 7 species, and among them was Conferva pectinalis, which now becomes Fragillaria pectinalis. 100 years later, Boyer designates Fragillaria pectinalis as the typus generis, so as the generic type for the genus Fragillaria. And in 2006, Aki Tuji and Dave Williams established the morphology of Fragillaria pectinalis. Yes, but, of course, there's a but. What is the key feature of the genus Fragillaria? According to Lingby, it says it makes long ribbon-like colonies, fila articulata, plana, simplissima, fragilia, and so on. So it means you need to have something like you see in this drawing from Dilwyn that makes long ribbon colonies where all the different valves, the different frustules are connected to each other. Tuji and Williams analyzed this original Dilwyn material and found something that hardly makes a colony. But David was so kind to send me some of this Dilwyn material, and in the raw non-treated material, I found exactly what Dilwyn and before him Müller have been drawing. So if we take again that drawing and we make a nice clean slide of it, you end up with this, which is hardly a Fragillaria. So Conferva pectinalis is this actually what we now call Eunotia sp, because there is no species. We have no idea what that species might be. The genus Eunotia was described in 1837 by Ehrenberg, which means 18 years after Fragillaria. So one of the things that I should do now is to recombine all Eunotia species as Fragillaria and have to come up with a solution for all the actual species of Fragillaria. I think if I do that, I better start looking for another job because I will be hunted by a lot of people for the rest of my life. So we will not do this, and we will try to find a solution how we can conserve this Conferva pectinalis in the way that it stays kind of the Fragillaria type. Wolf Henning Kusber and me, we are trying to find a good solution for it, but definitely I'm not going to recombine all Eunotia species. Absolutely not. Now, on the other side, the ecologists also have to show some resilience and some adaptiveness. In 2015, together with Carlos, we made a very nice paper on some ecologically important small naviculoids, Navicula seminolum, Navicula minima. And we came up with this scheme where you have in the bottom, in white, the older names, and on top in black, the new names. But as you can see, a lot of names like Navicula minima and Navicula seminolum either disappeared or got a new meaning. But this is something we could not have kept these old names and say, okay, let's now forever use these old names. So we had to use the new names. And for a lot of people, that was a huge change. But 7 years later, everybody normally is using these names. So both parties have to give in. So now comes the work of the detective in the museum. And you see here Wolf Henning Kusper in the Ehrenberg collection when I was visiting him last year in Berlin. There are two ways to start with it. You have algae base, you have diatom base, where you can find who described a certain type of a species, a certain species, not a certain type, but a certain species. And there is this outdated, but Charlotte, my student, is trying to resurrect this file from Hein de Wolf and Fritjof Sterrenberg with the survey of the Diatom collections. So we know a little bit where all these collections, or most of these collections, are, what is included in these collections. So we could actually start looking for material in these collections. And I'm going to give you the example of the Natural History Museum in Vienna, where you not only found the Venus of Wilmersdorf, which is a very famous prehistoric statue, but where you can also find huge collections, and also the famous Grunow collection. Now, the Grunow Diatom collection contains raw unmounted material. You have the accession books. Actually, it's a handwritten catalog Grunow provided. You have microscopic slides, Grunow made or received from colleagues, and you have the famous Grunow drawings. Now, these drawings, for instance, have been used to make one of the most famous books in the world of phycology, which is the Atlas from Van Heurck. And actually, this was the first Süßwasserflora. It was more because there was also marine in there, but it was actually one of the first diatom floras of its kind and still usable these days. And the one that you see here is the annotated by Grunow, the annotated version in Vienna. So now do you have to work in this collection? Let's say we want to work on a species named Fragillaria or Starozyra intermedia. You look at the drawings where the original species was published, and that was in the Van Heurck Atlas, and Grunow made his drawings in there. And if you don't have the annotated version, where you actually have also, as you can see here, Ormus B and 552, these are the samples that Grunow used. But if you don't have this, it works also, but it's easier if you can consult also the annotated version. And I think Tanya is going to work on that to see that people can use it. But you have to find for the Grunow collection, and that is a little bit special, you have to find the Tony number. And the Tony was an algologist or phycologist, sorry, of the late 19th century, who made a huge catalog, one of the first catalogs in its kind, and it's freely available. You can find the download URLs here. It's freely available, and you can find all the names that were known around 1892, 1894, 1891. You find the page number, you go to the page number, and on that page, you find actually an other number here, and 2545, and that is the Tony number. Now, why is this the Tony number so important? Because this is the number that Grunow used to catalog his collection. Or maybe, and that we are not entirely sure, that somebody else used to catalog Grunow's collection, at least the drawings of his collection, and with the drawings also the samples. So you go to 2545 and you get this nice sheet of drawings, and you find the drawing you need, and indeed this says Fragillaria Starozyra intermedia Grunow. And it also gives you here Van Heurck table 45, plate 45, figure number 10. And if you look indeed, that figure, that drawing was taken out of this drawing collection, and it was here in this gap. And that's when the Botanic Garden in Messe comes in as very handy, because we have the original plates for this atlas with all the cutouts. And if you compare this cutout with the actual drawing, you see that it was taken from this page. So we know that this valve was taken from that sample number 31. And if you have sample 31, you can start looking into his collection, in his annotation book, or his catalog. And there you see under sample 31, Fragillaria mesolepta, but also Fragillaria intermedia. So you know that this must be the sample that he used for Fragillaria intermedia, because that drawing is the original one for Fragillaria intermedia. Now, the problem is Grunow's handwriting is not the easiest. So Tanya, Paul, and a student, I think Veronica Herring, and me, we decided that we should make some kind of catalog or a translation guide how to translate Grunow's handwriting. And Tanya went through all the texts and tried to find all the letters and what these letters mean now, because Grunow used a mixture of Gothic German, of Austrian German, of fluent Roman type German, and he used the different handwritings mixed. So your samples are written in a different way than the species, which makes it kind of rather difficult sometimes to get his handwriting deciphered. But there is now a tool, and the paper is, I think, open access and will be available soon. It is in press at the moment. But then you have to go to see for material and slides. And there are two slides of 31. One is with this black ring, and this is an air-mounted slide. They have no mounting medium, and the problem is if you take pictures of that, this is not from sample 31, this is from another one, but it's an example. Yeah, the quality is not the best, but sometimes you're lucky and you have also one with Canada Bomb, Starex, Pleurax, Herax, and whatever. I think usually they made Starex and Pleurax, and then you see that you can have better pictures of that material. And then you have to search for the material. And this all takes quite some time because the Grunow collection is organized per sample number, but that is called the Grunow collection. That is his types. So there you can already have a first look. That's here in the back. There is the general collection, but they are organized per species name, and several samples can be found under a species name. The problem is, you have to find synonyms. You have to try to see, okay, maybe what was the thing named in the time of Grunow? Maybe he used an older name, maybe he used a more recent name, and so on. So this is not so easy to find. And I spent the first time when I was there 2 full days taking all these boxes and just writing down the numbers with the species that was written on those numbers. So there is a kind of catalog, but not for everything. I only did the freshwater genera because I was there for freshwater species. And then there's also the fossil collection, and they are organized again per sample number. But then again, there is no catalog of what number is there. So I also made a catalog for the fossil collection. So, and then you can find the material. And sometimes this material is a glass. Sometimes this material is dried on a paper, or these are boxes with diatomites or kieselguurs or bergmehl and so on. So you can start, if you're lucky, you can find some of this material. And then finally, if you put everything together, you can make a publication. And by the way, most of these small publications, I always put in Notule Algarum, which is from my quarry from algae base, a very, very nice and handy free way of publishing quickly these small things. And you can freely download all these papers from notulealgarum.org. I don't have shares in that thing, but I like the way how it is presented, and it's a very rapid and nice and clean way how to do small taxonomic papers. Now, all this work, does it lead to results? Yes. And I subdivided it in 4 types. One, when the results confirm what we already knew. These are the easy ones. I give the example of Eunocia exigua. Eunocia exigua is a species that everybody finds, that everybody knows. And yet, if you take Lange Berthelot's book from 2011, he writes, we never saw the type. Okay. We don't know where the type is. Now we have this huge Van Heurck collection in Messe, and by coincidence, I found the material from Brevison from the type of Hematidium exigua, and that's the current, that was the old name, and now is this Eunocia exigua. So we could make a small paper on it. And the good thing is that we can confirm that our current idea of Eunocia exigua, a lot of people were happy, is actually correct. But what is the purpose of such a work is that you can now also say, okay, that's a type material, we know it, and if somebody wants to use it for another study, that's the basis of the species Eunocia exigua. There were no drawings, there was nothing actually of Eunocia exigua. So now we have a full range of how Eunocia exigua in this population from Falaise in Normandy, from the Brevison looks like. We even could do some SEM analysis. So we now know how the original type that is linked to the name of Eunocia exigua looks like. And we could even, and that is actually the most interesting one, you can even start looking at species that are supposed to be synonyms and study them too, if you can find the material. And luckily for us, we also have the whole Hilse and the whole Smith collection in the Botanic Garden. So you could also reduce some names and help people. Second example is when the results show that you have to do a name change that will be necessary, but it will have no impact for ecology. Also interesting, because that means you can just simply change the name and you're still good. And that was another paper we made, and that was on Eunocia paludosa. And when I was in Vienna, I found the type material of Enosia paludosa, and to my surprise, it's a big, fat, huge species, which is completely different than what we think of Enosia paludosa in either the Antarctic or the Arctic, or even our acid fen systems and acid bog systems in Europe. The thing even has spines, and we know now that this is actually the same what Hustedt later describes as Enosia fenica. So Enosia fenica is unfortunately a younger, that name has to drop, is a younger synonym for Enosia paludosa. But what to do now, of course, now with the what we know as paludosa? Well, we just described it as a new species, Enosia sphagnicola, but it has the same ecology as all the Enosia paludosa, former paludosa populations that you have in Europe. So the advantage of this kind of studies is, apart that it keeps me busy, is that you can do some taxonomic correction and some stability, because now you have also the type and you say, okay, paludosa looks like this. But it's only a name change from paludosa to sphagnicola, or from fenica to paludosa, and it has no real ecological consequences. Of course, you have to be very careful that you're not starting to mess up paludosa sensu, what we know now, and paludosa like it was known before. Now, when the results show that the taxon concept is actually wrong, but it has no big impact for ecology. So ecologists are happy, taxonomists are happy because they can change something. And I'm going to give the example of Styrosara construens, a species that we probably all know, and that dear friend Ehrenberg described from material from Connecticut in United States, from New Haven, and that was Styrosara construens. And this is how we know Styrosara construens. So when I was visiting the Ehrenberg collection in August last year, I found the type material, and it was Paul Hamilton who actually studied it before, but it was never published. So we are doing this work now with Paul. And this is in there. But there's also this in there. So actually we have two different forms that look a little bit like Styrosara construens. But if you start to look again a little bit deeper into this publication that Ehrenberg wrote in 1843, you actually see that there is not only Styrosara construens, but there's a second species which is called Styrosara pinnata. And in construens, Ehrenberg did not draw any details, but on the contrary, for pinnata, he made some nice striae. So if we go and look back at our two populations that we found in this sample from New Haven, we have something with 14 to 16 striae that actually really resembles this pinnata more of. It has a central area and it has an axial area. And if you look at these pictures that I made from the type, they also have a central area and a broadening axial area. The other one, and that's also New Haven, that is what Styrosara construens is. It has no structure at all, because this one has 18, 19, and sometimes even 20 striae that does not leave too much space for an axial area. So Ehrenberg had nothing to hold on to see structure in it. So we believe that this one on the top is pinnata, and this one on the bottom is construens. But the good thing is, in all the samples that I've analyzed so far, not only Ehrenberg, but also modern samples, I find these two together. So that means that they probably have the same ecology, but they seem to, because I also have some samples where you either find construens or you find pinnata. So what is the advantage of this kind of study is that you can do some taxonomic correction, you can illustrate the variability a little bit better, and you can also offer solutions for taxa that you often see and often think, yeah, maybe it looks a little bit the same like that, but we are not sure. And we don't know if that is CF construens and that is construens, but you have now solutions for it, and it looks like that the ecological consequences are almost zero. But it has to be further investigated, and then that's when I rely on ecologists and a lot of people that analyze diatoms for water quality monitoring to see in what circumstances you find either one or the two or both species. Now, just a little sidestep is how I think what a good type material analysis should include. I think first you have to make a full documentation using light and, if possible, scanning electron microscopy, and show the morphological variability of the type population. And please, if you describe new species or you want to compare with a species, 2 light microscope pictures is definitely not enough. Make series from small to large. Even if you have to put 20 or 30 pictures in a plate, please do it. It helps readers afterwards. Also, highlight details on your pictures of important features so that the reader immediately sees, hey, I have to look at that spine, or I have to look at that apical pore field. And then what I think is very important, check other verified, or verify yourself, populations of the same species. So bring in a lot of samples where you can find the same species, or what you think is the same species, and start making pictures and compare these pictures, because that is a way how you can see how the variability of a species really is and how limited a species can be. And then start comparing that species with morphologically similar species. And very important, if you describe new species, please add a comparison table. It's a very handy tool, and it's not that much work. And in a publication, it always looks nice and handy for people that want to use your publication. And that is something that I call ecological profiling. Start to make some ecology of the population, especially the type population that you see. Now, the problem with ecological profiling is that, yeah, what to do with 19th century samples? Historic samples or 19th century samples, often from the first half of the 19th century, and that's the sample. So there is no ecological information or extremely poor ecological information. And the one here says that it was found on Hypnum falcatum in a spruce region of the Walden Valley in Italy or even Poland. They have no idea what Walden Valley, Walden tiles is exactly. And they found it in eine Lache. So I have no idea what it means, but they found it in some kind of geographical structure. The only problem is you have a date, 1864, but this Mr. Heufler or Heusler did actually not do any physical chemical measurements. The problem is I don't think the guy even had a pH meter, so he can't do this. But what we do have is we have the diatoms in the material, and they can tell us their story, and they can actually help us in trying to establish under what ecology your unknown or designated species taxon should be. So what I always do now is I look at all the species, well, the dominant species in the slide, and in these slides where you find your taxon quite frequently, it means that their ecology most likely might be relatively similar to the ecology of that species. And so, for instance, you can find out that the old Fragillaria gracilis, it's now Fragillaria radians, is actually something that is not that very oligotrophic that everybody thinks, but it's a little bit more mesotrophic in higher alkaline and higher electrolyte contents. So you can derive the ecology of the diatom in question by using the diatom composition of the rest, given, of course, that some of these species are well known and correctly identified, but some of these common ones probably are. Now, the last thing is, what I want to say is, does it lead to results? Yes, but what when the results show that the taxon concept is actually wrong and there are ecological implications. So then that's when the fun starts. And then that's where I started to work on my Brachyzara case in Europe. I have to say this is European stuff. Brachyzara has been put in a monograph by Horst and Gerd Moser in 1994, and they made a very nice book with a lot of populations. They had 32 new species, and the only thing is, and Horst knows that he made a mistake, most of them are described without analysis of the type material. Probably because Horst had no access, although I doubt for some of these species, but there is some problem. And the problem is that now these names of 1994 end up in the new standard identification guide that everybody uses in Europe. And you have a lot of species, about 15, I think, in Europe, and that is how you have to identify them. But it's not always given nice, good, clean results. So without analysis of the type, these are the species that Horst put in that book. And as you can see, some of them are based on old material, Brébisson, Grunow, and that material can be found. And this is Brébisson. This is Walker Arnold, also a Scottish diatomist who collected a lot, and we have almost his entire collection. And this is the only image that exists from Albert Grunow. But you have to go and look in all these old drawings that Grunow made, and I went through all these samples to try to find out a solution. And you see that this sample is 20, and that exists, and that material can be found, and that is the actual type of Brachyzara, or that way, Navicula zelensis. You can find it, so go for it and try to decipher it. And I'm going to show you the problem of Brachyzara neoexilis. It's a species everybody probably who is working in acid and alkaline environments and oligotrophic environments has found. And one of the things that struck me is that Horst writes that it's very indifferent to pH and conductivity, and that is abundant in both acid and alkaline water bodies. Now, I don't know a lot about acidity, but I find it really strange that the species can be so broad in pH tolerance that it goes from almost 4 or 5 to almost 8. So I had my doubts about this. Problem is, the type material from Horst is not available. But Horst wrote in his book, in this 2017 book, he wrote that there is also something called Brachyzara microcephala. And that comes from Pierre Compere's idea from 1988. So let's see what Pierre thought in 1988. And he says Brachyzara microcephala exists, but nobody has ever heard again of Brachyzara microcephala. So I started looking for the type material, and I found it. And the type material was actually hidden in the Smith collection. And this is how Brachyzara microcephala looks like. Unfortunately, I'm unable to find the type material of Brachyzara neoexilis from Horst because that collection is a mess, and we are trying to find out how we can get, again, access to it. But Grunow actually based everything, and Horst based it on that, on a species which is called Coletonema exile or Navicula exilis, Grunow, non-Navicula exilis, Kützing, because that's a real Navicula. And that material could be found. And if you study that material, you see that you have actually a quite different species than microcephala. So we have something pointy, acutely rounded, and you have something capitate and a little bit more fat, a little bit more elliptic lanceolate. And moreover, all the populations from microcephala that I studied all ended up in weakly to moderately acidic freshwater habitats, whereas the other one, the neoexilis, is more circumneutral, slightly acid, 6.5, but to very highly alkaline. And so my colleagues in Sweden who work a lot with these species are now very happy because they now can actually use their acidity index in a correct way, because microcephala, or neoexilis as they call it, which is a dominant taxa in a lot of lakes and rivers in Sweden, actually now makes sense that it's only pointing to not alkaline, not acid, but alkaline circumneutral conditions. There's another one, and then I stop, I promise. That's Brachycera styriaca, and that is described from Styria, and Styria is a province in Austria. And it was described from a lake called Erlafsee, or Erlaufsee, Lake Erlaf, it still exists. And it was a calcium carbonate enriched lake with a high pH, and the diatom flora in that lake is highly alkaliphilous, but the type was never studied. And this species pops up in a lot of studies from acid bog ponds in Northern Europe. Something, for me, something was not completely right. And even Horst writes in his book that the pH is very indifferent, and I actually didn't believe that. So I started looking for the sample from the Erlaufsee, and that's what I found. And I started looking for the material from a population in Scandinavia. I found the Walker Arnold sample from Kristiansund in Norway. And this is what I found. And it may seem small, but there are actually differences. And actually, this species was actually described by Cleve Euler, Astrid Cleve, or Cleve Euler, like when she was married with the mathematician Euler, Cleve Euler. She described this as Brachycera Anemones decipiens. Now it's Brachycera decipiens. And this is the species you find in the acid conditions, whereas the styriaca is something that you only can find in alkaline conditions. And there are, if you look at several populations, you can say, okay, these are the morphological differences. So the advantage of these Brachycera studies is that you have a taxonomic correction, you have a better illustration of the variability or sometimes the non-variability, you have a better ecological characterization of these species, and they are now better appropriate for biomonitoring. For those who want, we made 3 papers on all these Brachyceras in Europe. There's a 4th one that I was writing up today, and even Brachycera vitrea is also a mess with a lot of hidden species under one name. And for those who will visit us in May for the European Diatom meeting, there will be a new taxonomic workshop right after the meeting. But so, what is the take-home message is that taxonomists are there to make the life of ecologists complicated. No, sorry, that was for a different talk. Taxonomy is an important science to solve confusion and unclear situations. But it's a science and should therefore only be done by experienced taxonomy scientists. I don't say that people doing only ecology cannot be experienced taxonomic scientists, but please let the taxonomy to people that really work in taxonomy. These taxonomic results that we have can have consequences for the interpretation of the ecology. And I think that type analysis is crucial to solve taxonomic problems, but it's only the base of it. It's the first brick you put down to build your house, but that brick needs to be correct. Taxonomy and type analysis is not going to solve the world problems, but it's a start to at least get the right face to the right name. And afterwards, this is the material other people have to start working with it. Because we taxonomists need the ecologists to indicate the problems and to see if we can find solutions. Look at the Brachycera problem. An ecologist, I believe, will need taxonomists to increase the power of the ecological information they want to get out of their samples. And I'm not only talking about paleoecologists, but also on freshwater ecologists working, for instance, in water quality monitoring. Now, what brings the future? I think in taxonomy, there are the last 10, 15 years, the application of new methods. For instance, molecular science. People, this is a tool. This is not the Bible. Molecular science is a tool, as is microscopy. But both should be used. And Maria Carlot and her group did some very nice work. There are some problems, but we can solve them on Fragillaria using more molecular science. And these are very important steps in taxonomic science, and we should combine them. Problem was, there's a lack of critical taxonomic analysis. They say everything is a species, and so some of the strains are not correctly identified, and none of the types, even if you can't do DNA on them, you can still use the morphology to compare to your strains. That's a lack which was not done, but that can be corrected. So that's not the big problem. The nice thing is that these papers meant a step forward. I think another thing that in the future will come, and we are working on that, is that there is a better accessibility of Diatom collections. By digitalizing these collections, online publication of type populations, and online publication of verified populations. It's so easy these days to get things online and shown to everybody. And I think that the Diatoms of North America and what Ingrid is doing with the Diatom flora of Britain and Ireland are very top-end examples how it should be done. And these things are in the continuous move and a continuous change. And that is very important because it's not static anymore. You can correct mistakes immediately. And my dream would be is if we could couple the type analysis with genetic analysis of a modern population. And of course, I know after the work of Evelyn Pinsale on Pinaria borealis that it's not always because morphologically it looks similar that it is similar, but I do think that we could actually, if we put the types in here with all these populations and that these are the types, then we can have actually a better idea of some of these phylogenies. So I think I will stop here. Thank everybody, of course, my team, David, not my team, the team, David, Luc, Carlos, Tanya, Wolf, Henning, and Paul, for helping me with a lot of these problems. My colleagues in Messe, for listening to my cursing every day when I discover again something that is not completely how it should be. Of course, my boss, because he allows me to do this work, because actually I should do something else, but he says, just please have fun. And actually all these Diatom collections that are opening their collections again, and this is very, very, very important. And I have to thank you for continuous inspiration, because if you don't come up with a problem that you want us to solve, we can't find that problem. So thanks a lot.
Awesome job, Bart. Thank you very much. Of course, I have a burning question as far as how the Eunotia fragillaria problem will be resolved, and maybe you could tell me to just sit in my hands and wait for the paper to come out.
To be honest, I had to put it a little bit aside because I had to deal with other problems first, but we are preparing a book on the Fragillaria genus in Europe. It will be a Diatoms of Europe, but it will only contain European species, but it will be also of interest for North America because you have a lot of European species which are not European species, but all the types will be in there. And before we publish the book, that problem should be solved. So we are thinking how we have to conserve it, maybe we can see if we can find another type, because the only thing that is in there that is a Fragillaria is actually, this non-colony forming pectinalis, what Aki and Dave called Fragillaria pectinalis. So we are trying to see if we can save that pectinalis, because honestly, I really don't want to start messing up with renaming all Eunocias as a Fragillaria and so on, because everybody is not going to like me, I'm afraid. So sure. We will find solutions, but at the moment, we are going to propose a conservation, but that is a very, very long and slow process. But it will come eventually.
Yeah, and I'm also thinking there's a Eunotia pectinalis that you have to also worry about.
Yes. But that's not the, yeah. But if we conserve Conserva pectinalis for the Fragillaria, we have to rename the Eunotia something different. So it can be Neopectinalis or whatever, pseudo-pectinalis, whatever. We'll find something.
Yeah. If anybody else has any questions, feel free to raise your hand and you can ask Bart yourself or drop them in the chat. There is one brief question about the workshop in May. Is there any chance that it will be online?
I'm afraid not. But what I can do afterwards is for those who want, the booklet will be made available via the website of the Dutch Flemish Diatom Society. It will have some delay because, okay, people have to pay to join the workshop, and I don't want to give things freely afterwards, but it will be available. After a year, it will be available. And I think it will also be useful for the people in other continents, because we nail the types and we say, okay, this is how the type looks, this is how variable it is, and these are the species that we're used to name like that, and we have to name it now differently. And usually we find old names that already exist, like these decipients. It was there, it was simply forgotten, and it was probably Husted's fault, because he had a fight with Clave Euler. He writes it somewhere. You stupid woman, he writes in there. He was very mean to her from time to time. So it's not in that wording, but he was very mean to what she was saying. And so things got, yeah, lost.
Got personal, yeah.
It was personal. I think it was personal, yeah.
Dr. Edlin, do you have a question?
Yeah, thanks, Bart. Great talk. I wanted to get some of your thoughts on what your advice to people who want to visit museums might be. What kind of, what their expectations, how long should they visit when they want to visit a museum? How much work can they expect to get done on a visit to a museum?
Well, first of all, it depends how much work can you do before you go to a museum. Before I go to Vienna or Berlin or London, I prepare 2 weeks nonstop, going through all these old books, all this old literature, and there's an amazing amount of literature freely available by Biodiversity Heritage Library and so on. So all these old things you can find. But it's really like a detective work, because you have to read a text and then say, oh, yeah, but he wrote in that paper something else, and you have to combine things. And then you find where the type might be. And if you know, and I have my small booklet, and I write in there, I need that one there, and that one there, and that one there. And then I know when I come in the museum that, okay, I need these samples. And that saves you time, because you know what you're looking for. And that's the easy thing. And it depends how many species you want to work on. If you say, I want to do all the eunochias, yeah, good luck. But if you say, I want to work only on the 5 tetracycline species in that collection, it limits. And don't make the mistake I made at the beginning. Try to do too much, because you end up with less than you wanted, and even a lot less than you wanted. Because there's always a problem that will pop up.
Are you finding that most of the collections have good microscopes available for analyzing and digitizing things?
Can you repeat?
Oh, are you finding that most museums have good quality microscopes for analyzing and digitizing material?
No.
Okay.
Actually, yes, but not for me. I have one of the top-end microscopes here, and I know how to make the pictures, and I know how to get the most out of the machine. And a lot of these other microscopes are okay, but I cannot reach what I get. And maybe I'm the lucky guy, but I have a good connection with a lot of the curators, and sometimes I manage to convince them that I can get some material and work on it at home. So I usually, things that I really can't solve, I try to take home, or I let it sent to me and I try to do it. Or in case, for instance, with the Grunow collection, the slides cannot leave the Grunow collection.
Okay.
So Tanya Schuster visited me and had the slides with her. I could take the pictures here, and she took the slides back with her. So technically, they never left the museum because they were with the curator. But this is not the way how it should be done. You should make pictures over there, and usually you can.
Okay.
And the pictures are okay, but for some of these fine things, it doesn't work.
Thank you, Bart.
Right, Roxana, you have a question?
Hello. Yes. Can you hear me?
Yes. Hi, Roxana.
My connection is not great, so you may not hear the whole question, but I will try. So thank you, Bart, for this really nice presentation. I'm really happy to see that there are people who care about this, and actually there's quite a lot of people listening to the talk. So I guess it's a good sign. I have a question about your advice or your thoughts on the situation where you can't access the type material because it's in somebody's private collection and the person simply does not want to collaborate. And then there's maybe the second question linked to that, because as far as I know, currently it is not required that when you describe a new species or a new taxon, you need to send the type material to a museum or some institute where it could be accessed by everyone, right? So
it needs to be in a publicly open collection. And if you want to keep them at home with you, that's fine. But if somebody needs it, you have to share it with that person, or at least have that person access to it.
Mhm.
In case if there's somebody who blocks the material, that is simply not done.
So then I can call the taxonomic police and they will assist
There
me.
is no taxonomic police. The only thing what you can do is ask some taxonomists and see if they can help you and find the way into the collection. Because sometimes if it's a personal problem, a person cannot be the enemy of the whole world. So there might be somebody who has access and try to go by somebody else.
But then we get
But
to
I
the
know in
situation
some
when
cases-
science becomes personal. It's not right, isn't it?
No. I know, but I'm afraid there is nothing we can do about this. And I honestly have never really encountered a real problem like that where we cannot find another solution, because when in that case, I start to try for other solutions. For instance, the Yuma Oki booklet, that's Iconographia #2, was based on one sample that Horst received from that lake in Finland. But I have the slide, the original slide I have in my lab here at home even. But the material is no longer accessible. So I asked people in Finland, and they were so kind to go again to that lake and took new samples for me. And I found most of the species again. So technically it's not the type material, but it's the closest you can get from the type material. And you cannot say that this is the type material you studied, but you can say this is a population from the type locality that shows no morphological difference, mark my words, morphological difference from the one that was sampled 25, 30, 50, 60 years ago. So sometimes that's also a solution.
Do you think it would be?
And sometimes, sorry to interrupt, one more thing. Sometimes you can overcome the problem by looking for a population that is very, very, very similar, and that you say, I think it's the same, and then you designate an eptype for it. And then you say the original material is no longer available, so we cannot study it anymore, but we can make a new type, and you make an eptype, and then you have the type, and all your problems are solved.
But do you think it would be useful if perhaps someone could amend the code, I guess, so that there is a requirement for the type material to be stored at a place where it is accessible and properly managed?
It is already in the code. Because
I think it's a recommendation, isn't it?
I don't know. I have to check. But it can be a recommendation. But yes, I will talk to Wolf Henning Kusper and ask him if that could be a solution.
Okay.
Yeah.
Thank you.
All right, we have time for one more question. Tom, if you can sneak it in here.
Yeah, I'll sneak it in quick. Bart, thank you. That's excellent. And yeah, you know, these types are so important. And I'd like to say a couple things, or ask any possibility of making a monograph or a small book, something like, you know, for the Grunow collection, something like David Williams' Grudel collection book, or Simonson's Houston books. And I'd like to make a request to everyone out there, if anyone has any European material of Hylosyra interrupta, I'm looking for the types of that, which seems to, physical types don't seem to exist.
The problem is, Tom, for Grunow, it's not going to be a small book.
Yeah.
There are about 3,000 samples to go through, and he described hundreds of species. And it would require a lifetime job to do this. And I try to tackle genera, not the ones that I like, but the ones that I think we should work on, where I see that it's important, like Brachycera, like Fragillaria. I start working on Fragillaria. Nobody wants to work on Fragillaria, but I tried it, and it starts to work. But so you have to come up with a group and work on that, because Grunow collection is too huge. That's like somebody like Reimer Simonsen. He was in the Husted collection, but that was his only job, being in the Husted collection. So he could only do this. And the problem is also that the person who is the curator of the Grunow collection, she's not a diatomist. She's a higher plant scientist who now works as a cryptogam curator. And Tanya is extremely learning very fast about diatoms, but you cannot expect her to replace a 25-year experienced diatomist. She learns a lot, and she's very good in the things that she does already with diatoms, because we work a lot together. You can see that on the papers. We make a lot of papers together. And she helps a very critical idea as a non-diatomist what we do, but she's not a diatomist. So there is nobody there. They are understaffed. She has to deal with all the cryptogams, from lichens to mushrooms to diatoms. And if you have money for somebody to pay for 4 years, it can be done. But it's somebody who only works on the Grunow collection and only makes pictures and only prepares all this material. Because I've been working on 70 species from all over Europe from Fragillaria, and I'm already working 3 full years on it, and I still need another 3 years. So it's a wonderful task that you propose, but it's an impossible one.
Gotcha.
I'm sorry.
Yeah.
All right. Well, yeah, great questions. And Bart, thanks again for such a wonderful talk. We'll get it uploaded to YouTube here later today. Another round of applause, virtual